Today's question: three infinitely long straight rods A, B, and C are fixed in the xy plane, forming an equilateral triangle. The currents in these rods are as follows. The current in rod A is I0. It flows in the positive x direction. The current in rod B is also I0. Its direction not given. And the current in rod C is given as IC, and its direction is also not given. Point O is the center of the circle, and the circle intersects rod A and C such that the point of intersection is at a distance 2d from P and Q respectively. Points P, Q, and R lie on the circumference of the circle. The magnetic field strength due to each flowing current at the reference point O at a distance d from the wire is B0. The net magnetic field strength due to currents in the rod A, B, C at point P and Q are as follows. The net magnetic field at point P is 0, and the net magnetic field at point Q is 3B0. What is the magnetic field strength at point R caused by the current flowing through rod A, B, and C? So this is the basic figure. Three rods A, B, C are arranged such that they form an equilateral triangle, and a circle is drawn such that it consists of 3 points P, Q, and R, and the respective distance of between P and the you can say the point of intersection of rod A and B is 2d, and similarly obviously for the other ends also it will be 2d. So this is basic diagram, and we have to find out the magnetic field strength at this point R. In order to find out the magnetic field strength, we should be knowing the direction of current which will be flowing in rod B. We only know its magnitude, that is given as I0. And the current in C is given as IC, and we have to find out what is the relationship between this IC and I0. This is to be found out, and its direction as well, because then only we can find out the net magnetic field at point R. And only thing which are given to us is with respect to current is it flows through rod A in positive x direction. So it means current is flowing in this direction, as the arrow is marked also here, and its value is I0. And as a reference it is given that at a distance d the magnetic field is given as B0. So we are going to use this as a standard, you can say, reference formula, and start from here only. So we say magnetic field at magnetic field at point A magnetic field at point O due to current flowing in rod A, due to current flowing in rod A, which is our B0, and this B0 will be equal to K multiplied by I0, that is current, and the distance between the center and this. So the perpendicular distance with the rod with respect to this point O is given as d. So this B0 is our reference field. We are going to modify rest of the equation based on this B0 only. And it is also given the direction of current of I. So we are given the current in the rod A flows in the positive x direction. Current in the rod A flows in the positive x direction. So So we are going to use this rod A and find out the magnetic field at point P as well as point Q. So let us draw a approximate. So this is our rod A, and current I0 is flowing in the positive x direction, and point P is somewhere here at a distance of 2d. This is point P. Similarly, we have a point Q which is just opposite to point P, so its distance from rod A will be also equal to 2d. So let's find out what will be the magnetic field at point P and then magnetic field at point Q from rod A. So we start with our rod A. And at point P, the magnetic field at point P, the magnetic field let us suppose that is given as B naught A, and with respect to point P, and this will be equal to half multiplied by B naught, because the reference formula is with respect to distance d. Here the distance is 2d, so obviously it will be coming as half of B naught, and its direction will be outwards. Outward direction, because in order to find out net magnetic field, we should be knowing the magnitude as well as direction. So for at point P, it's an outward direction, and let us make similar analysis for point Q. So we say at point Q, the magnetic field let us suppose that is given as B naught A at point Q, and its value B naught A at point Q, this will be also equal to half B naught, and its direction will be also out of the paper, outward, or we can say out of the paper. Now we are going to consider rod B, and for rod B we are going to assume a certain direction of the current. Rod B, so the rod B is something like this, and this is our rod B, and we assume that the current whose magnitude is given is I naught is flowing toward the lower left. Okay. And the point P is somewhere here, its distance is capital D, small d, sorry, is D, and point Q is just opposite to here somewhere, and its distance is 2d. This is point Q. So we assume I naught direction to lower left. Similarly, we find out the magnetic field at point P as well as at point Q. So we say for point P, at point P, magnetic field let us suppose that is given as B naught B at point P, and which will be coming as equal to B naught, and its direction will be into the paper. Into the paper. Now similarly for point Q, at point Q, the magnetic field and let us suppose that is given as B naught B at point Q, and that will be equal to half B naught, and it will be out of the paper. So this is also we can consider. We have done rod A, and we just discussed that the direction of current for rod B is the left lower, and these are the various distances calculated for this particular thing. Now we are going to consider rod C, and rod C we assume that the current is flowing up the, we can say, upper left, upward direction, and the magnitude is given as IC. So IC is flowing up left. So now is our rod C. And we assume current is flowing upper left. And we have this figure something like this. So this is rod C. Current we assume is flowing upper left, and we have P point somewhere here, and its distance is given as 2d, and Q will be just opposite to it somewhere here, and its distance is d. So we are going to find out the magnitude as well direction for rod C at point P and Q. So once again, at point P we get B naught because of rod C at point P, it will be equal to half B naught, and its direction will be out of the paper. And then comes point Q. At point Q, its magnetic field is BOC at point Q will be equal to B naught, and its direction will be into the paper. So we found out all the magnetic fields with respect to the, you can say, the currents. Okay, herein to find out the magnetic field because of C, rod C, current is given as IC, but we assume that this value of current is equal to I naught. Okay, we say assume, and later on we are going to verify whether this assumption is correct or not, along with the direction also. So let us prepare a table for the various values which we just calculated. So we have 2 points P and Q. We have rod A, we have rod B, and we have rod C. For rod A at point P, we got half B naught, and for rod A at point Q, we also got half B naught along with their direction, and for B we have B naught, and we have here half B naught, and for rod C we have half B naught, and we have B naught. Now net field respectively at net magnetic field. So net magnetic field will be summation of all the respective fields along with their sign. So we can write this as half B naught minus B naught plus half B naught. Okay. So we have taken the inward as negative and outward as positive. So this gives us equal to 0. Similarly, for Q also, we add them, we get half B naught minus plus half B naught, and plus it will minus B naught, and this will be also coming equal to 0. Now we have to check, because there are condition given to us that the net magnetic field at P is 0, whereas net magnetic field at point Q is 3 B naught. Okay. So according to this condition, the net magnetic field at Q has to be 3 B naught rather, but here it is 0. So obviously the assumption which we assume along with the direction and magnitude of current IC, we assume that the magnitude of current IC is I naught. Both these assumptions are incorrect. Okay. So we can say, as per given condition, as per given, net magnetic field at P should be equal to 0, whereas Q should be equal to 3 times B naught, and these two conditions should be true. But the calculated value calculated value, no doubt P is our 0, but Q is also 0. So these two conditions do not match with each other. So they are in contradiction. So we can say these, let us call this as 1 and this as 2. These 1 and 2 are in contradiction. So it means we cannot have value of IC as I naught, and obviously because that results in the different formulation or not matching the formulation. Now we fix, you can say, the value of current. Now we change the direction. We assume, like in this figure, the direction of current in B is taken at upward and direction of current of C is taken at downward. So we start from all over again and do the entire calculation for these two conditions, because for A everything is fixed, but for B and C it is going to now change. Okay. So we say for rod B, the current direction is taken as to upper right, So once again let us draw rod B. So this is our rod B, and we have current direction, current value I naught in upward direction, and once again we do same calculation. This is your point P at a distance D from the rod, and this is our point Q at a distance 2D from the rod. So we say at point P, the magnetic field, that is B prime OB at point P, this will be B naught and out of the paper. Similarly, we do it for our point Q. At point Q, we write it as B prime OB at point Q will be equal to half B naught, and that will be now into the paper. Now once again we come back to rod C, and we assume that is flowing in downward direction, whose value of current is given as IC. So this is rod C, and we have point P somewhere here. Distance of this is given as 2D, and point Q somewhere here. Distance of this is given as D. Okay. And for point P, we get the magnetic field as B prime OC at point P, and in this case also let us assume for the time being that the current value is still I naught. Okay, or we can say K multiplied by I naught. It will be much better. IC is assumed to be K multiplied by I naught. We are going to find out the value of K later on. Okay. So this comes as our K by 2 times B naught, and will be into the paper. For point Q, we have B prime OC point Q. This will be coming as K multiplied by B naught, and this will be over out of the paper. Now once again we draw the table. And we have P, Q, we have rod A, B and C, and for rod A everything was same, so this was half B naught, and this will also equal to half B naught. This comes as B naught, and this comes also half B naught. And like I said, that this will be K by 2 B naught, and this comes as K multiplied by B naught. Once again, we are given a condition that magnetic field at P should be equal to 0. This condition has to be satisfied. It means if we find out net magnetic field, the summation of all these magnetic fields should be equal to 0. So it means I should be getting this as half plus 1 minus K by, because let's ignore for B naught for sake of calculation, this should be equal to 0. And if we solve this, we can get that value of K will be equal to 3. Value of K will be equal to 3. So therefore, we can write this as 3 by 2. Here comes 3 B naught, and this we can also say will be about 3, and this will be also 3, and IC will be equal to 3 times I naught. And for net field, magnetic field for Q also, if we add only the values, so we get this is half, and we get minus of half, and this we get minus of 3, and this will be B naught, so half and half goes away, and this comes minus of B naught. So with respect to magnitude at point Q, we get that the magnetic field is 3 B naught. So this is same as our given condition. So we can say for a given condition, we have magnetic field at P, net magnetic field rather, should be equal to 0. Net magnetic field at Q should be equal to 3 B naught, and the calculated value we have magnetic field at P is equal to 0, and at Q it comes as 3 times B naught. So it means our assumptions regarding the direction as well as the value of IC is correct. Okay. So we can draw a final figure. So we can say for A it is already given that this is current I naught flowing in positive x direction. For B, this will be value of the current I naught direction as well, and for C, this is B, and for C the direction will be in the downward direction, and the current value is I naught, so this is rod C, and we have to find out the magnetic field at point R, which is somewhere here. So this distance is given from rod A is D, and the distance from rod B is 2D, as well as distance from rod C is also 2D. So now it is quite simple. We got all the values, necessary required values. So we say for point R, rod A, we can write that B naught A double prime at point R will be equal to B naught, and this will be into the paper. Now is our rod B. So we can say magnetic field because of rod B at point R, this will be coming as half B naught, and this will be also into the paper. And the last is our rod C. So we get magnetic field at point R and rod C. We get this as 3/2 because current is 3 I naught, and this will be B naught and also into the paper. Now we can easily find out what will be our net magnetic field. So we can say net magnetic field will be equal to minus B naught minus half B naught and minus 3/2 B naught, and this gives us that magnetic field, let me write it, net magnetic field. So we can say B naught net will be equal to this comes as minus 2 minus 1 and minus 3 divided by 2 by B naught, and this comes minus 6 by 2 B naught, and the magnitude will be equal to 3 times B naught. So this is the magnetic field at point R because of all the 3 rods. This is the magnetic field at point R due to rods A, B and C. So this question was little bit, you can say, tricky, because here the direction of the electric current in both B and C was not given, and the value of the current which is flowing on C was given as IC. So we have to find out the relationship between all the 3 things, and we have to keep everything in mind that the entire question is based on the given information, which states that net magnetic field at point P and Q is as follows. So it is always point P is 0 and point Q is equal to 3 B naught. So entire question or calculation is based on this one important point. So this completes the question. Thank you.